Betelgeuse is an enormous red supergiant situated in the constellation of Orion. It has enchanted people for centuries with its palpable crimson glow, and astronomers have estimated its enormous size. If Betelgeuse were situated at the heart of our solar system, it would devour every planet up to Jupiter. This star's size signifies that it is nearing the end of its lifespan, like it's preparing for a disastrous explosion known as a supernova. In recent times, Betelgeuse has demonstrated extraordinarily unusual behavior. Its brightness increased by more than 50%, catapulting it from the 10th to the 7th most brilliant star in the sky. This unexpected flare of brightness led scientists scrambling for answers. Was this a warning sign of its explosive death, or just a brief blip in its life cycle? The resulting effects are enormous. If Betelgeuse were to continue, it could make the night sky brighter, to the point where it would blur the distinction between day and night, creating exceptional opportunities for science. A star's size affects its brightness, temperature, and distance from Earth. Betelgeuse, with a radius more than 700 times the Sun's and a relatively cooler surface temperature of 3000 Kelvin, gets its red color from its size and low temperature, making it a prime candidate for a supernova. This makes its behavior all the more intriguing. In late 2019, Betelgeuse stunned astronomers yet again by dimming to 40% of its typical brightness. This significant shift was visible without the use of telescopes, sparking widespread discussions and observations. Some considered the possibility that dust had obscured the star, while others took into account internal processes. The possibility of a supernova occurring soon became a significant topic among experts. Astronomers using Chile's Very Large Telescope (VLT) managed to capture detailed images of Betelgeuse as it faded. These images revealed that the star had become clearly lopsided in appearance. Further analysis suggested that this dimming was probably brought on by a massive mass ejection from the surface, where Betelgeuse expelled an extraordinary quantity of material into space. This unprecedented event altered the star's appearance and threw off its pulsation cycle. The incident resembled a cosmic-scale eruption of volcanic activity, as Betelgeuse spit out more than 400 billion tons of material, much more than usual. This change in the star's activities not only altered its appearance, but also shortened its expansion period from 400 days to just 200. These major changes indicated it is becoming more unstable, leading to more questions about how long it can maintain its current form. Because of its erratic behavior, astronomers have stepped up their surveillance efforts, eagerly looking for evidence of an impending collapse. When a massive star like Betelgeuse uses up its nuclear fuel, its core collapses under the weight of its own gravity, triggering a supernova. This colossal explosion ejects a tremendous amount of energy, blasting the star's outer layers into space and producing a brilliant light visible even in daylight. If Betelgeuse bursts into flames, the first signal would be a burst of neutrinos, tiny subatomic particles that move more quickly than light and are able to escape the star. These neutrinos would reach Earth hours before the explosion's light itself. When the light finally appears, Betelgeuse may shine brighter than the eerie shadows cast by the full moon, illuminating the night sky for weeks. A supernova with this much power would provide an unprecedented chance for scientists to investigate star death in real time. By analyzing the emitted light, heat, and radiation, researchers could gather essential data regarding nuclear physics, star formation, and the formation of essential components for life. To understand Betelgeuse's unusual behavior, researchers are using sophisticated star model simulations of its interior. These virtual models incorporate data from telescopes like the James Webb Space Telescope (JWST) and the VLT, allowing researchers to delve into the processes driving Betelgeuse's instability. Simulations suggest that a significant gas bubble probably formed deep within the star, triggering and changing the rhythm of its pulsation. Observations from the JWST have provided a closer look at the debris thrown by Betelgeuse, revealing complex structures of gas and dust surrounding the star. According to these findings, Betelgeuse may be nearing the end stages of its life cycle, offering an unprecedented glimpse into the life of massive stars. Scientists predict that Betelgeuse could go supernova within the next 10,000 to 100,000 years, but its unpredictable behavior suggests this timeline may be significantly shorter. The astronomical community is racing to capture every detail of this cosmic spectacle before its dramatic climax to ensure that no one misses this rare event. In late 2023, the JWST, with its unrivaled capabilities, focused on Betelgeuse and uncovered startling new phenomena. Scientists discovered that the star, already in an unstable state as a result of its massive ejection of surface mass, had suffered an immediate internal collapse. These significant indicators of collapse included changes in its core dynamics, which altered how nuclear fusion occurred. Astronomers observed significant fluctuations in Betelgeuse's expansion cycles. Before the collapse, the star's surface expanded and contracted steadily for more than 400 days. After, this rhythm was abruptly shortened to just 200 days, indicating a significant disruption in the star's internal structure. These uneven rhythms served as a cosmic heartbeat, signaling that Betelgeuse might be approaching the end of its life as an enormous red supergiant. Simulations conducted by astrophysicists revealed that the star's core is becoming more unstable as it fuses heavier substances. When stars reach this phase, they begin producing iron, a process that denotes the final stage before collapse. Unlike other components, iron does not produce energy when fused, resulting in a mass accumulation that eventually leads to the core's collapse. Betelgeuse's recent behavior has sparked heated debates among astronomers regarding the timeline for its supernova. Some contend that the explosion could occur within the next few centuries, while others believe it could still be thousands of years away. What is clear, however, is that Betelgeuse's time as a red supergiant is coming to an end. A supernova is imminent. A surge in neutrino activity, tiny subatomic particles that escape from the star's core moments before it collapses, is expected. Scientists are keeping a close eye on Betelgeuse, monitoring for sudden increases in neutrino activity and using tools in its vicinity. The entire world is on high alert for this brief signal, which may provide humanity's initial real-time warning of a supernova that is about to occur. The supernova in Betelgeuse will be an incredible, inspiring celestial event, visible even during the day. Scientists assure us that, although it does not pose a threat to Earth, its brightness could rival that of the full moon, casting strange shadows and illuminating the night sky for weeks. Not only will this event captivate stargazers, but it will also offer an unparalleled opportunity for researchers to examine stellar death in real time. The story of Betelgeuse reminds us that there are still many mysteries in the universe waiting to be discovered. This enormous star, which has captivated humanity for centuries, continues to challenge our comprehension of stellar evolution and cosmic dynamics. With its mass ejections, dimming, and unpredictable behavior, it serves as a reminder of how much more there is for us to learn. The potential for Betelgeuse to explode offers scientists an extraordinary chance to learn about the life cycle of massive stars firsthand. Understanding these processes goes beyond dismantling the fate of one star. It's about unlocking the mechanisms that shape galaxies, seed the universe with vital elements, and even make life possible. This information enhances our comprehension of the universe's history and our place in it. The study tools we use, from ground-based telescopes like the Very Large Telescope to cutting-edge instruments like the James Webb Space Telescope, have opened up brand new doors into the universe that past generations could only dream of. With these technologies, we can carry out simulations, investigate the motion of stars, and peer billions of years into the past to gain a deeper comprehension of the very fabric of reality. For researchers like Neil deGrasse Tyson, discoveries like these bring a sense of urgency and excitement. They push the boundaries of human knowledge and challenge us to keep exploring the cosmos. The next time you look up at Orion's belt, keep in mind that one of those points of light tells the story of a star on the brink of its destiny. What do you think will happen to Betelgeuse? Are we witnessing the waning stages of a star about to burst into flames, or is it another phase in its mysterious life cycle? Share your thoughts and join the discussion of one of the universe's most intriguing stars. Don't forget to like, subscribe, and turn on notifications for more stories about the cosmos that will inspire you to keep reading. This time, keep an eye on the sky because we are closely monitoring Betelgeuse and its behavior. It becomes clear that this star is not merely a fleeting occurrence in the night sky. Its unusual activity is providing astronomers with rare opportunities to study the intricate processes that control how massive stars change. Every shift in brightness, every mass ejection from its surface, and every sudden change in pulsation patterns brings us one step closer to comprehending the mechanics of stellar life cycles. One of the most intriguing features of Betelgeuse is that it has changed over time. It is in a relatively uncommon stage of its life cycle as a red supergiant. Betelgeuse is nearing the end of its life, but its path to a supernova isn't as straightforward as it might seem. The specific reasons for the irregularities in its behavior are still being debated by scientists. While the surface mass ejection is one of the most dramatic events observed so far, it could be just the beginning of a more complex series of changes that lead to the star's eventual explosion. How fascinating is Betelgeuse's supernova? It could provide answers to some of the most important questions in astronomy. The sudden death of a star like Betelgeuse holds the potential to reveal secrets about the nature of dark matter, the growth of the universe, and the intricate processes that lead to the formation of new stars and planets. These revelations may assist scientists in improving current models of the cosmos and acquiring a deeper comprehension of the universe's evolution over billions of years. Research based on Betelgeuse is a component of a broader effort by the global astronomical community to understand the life cycles of massive stars. By studying stars like Betelgeuse, scientists can learn about the final stages of stellar evolution, which are notoriously difficult to observe in real time. Most stars die in extraordinary, distant, and difficult to observe ways, so when a star like Betelgeuse begins to show signs of its final explosion, it offers an exceptional opportunity to observe this cosmic process up close. One unanswered question concerns how long it will be before Betelgeuse finally reaches the supernova stage. The timeline of the star's demise is still a mystery, and scientists are constantly updating their predictions with new information. Some astronomers believe that Betelgeuse could explode sooner than expected, while others believe it may take tens of thousands of years before the supernova appears. Regardless of when it happens, the excitement surrounding the star's eventual explosion can still be felt. For now, researchers continue to monitor Betelgeuse closely, using a variety of sophisticated techniques to capture every bit of data they can. From ground-based observatories like the Very Large Telescope to space telescopes like the James Webb Space Telescope, scientists are making use of the most recent technology to peer into the depths of this enormous star. The data they collect will assist in enhancing our comprehension of stellar evolution and provide insights into the driving forces of the universe itself. As Betelgeuse's story unfolds, it serves as a powerful reminder of the vastness and complexity of the cosmos. Many stars in the universe are moving through amazing transformations, but few offer such a clear window into the final stages of a star's life as Betelgeuse does. Its impending supernova will be a monumental event, one that could help scientists answer some of the most profound questions about the nature of galaxies, stars, and the universe as a whole. While we may not yet know exactly when Betelgeuse will explode, one thing is certain: its death will be a significant occasion in the study of stellar evolution. For scientists and astronomers worldwide, it will provide countless opportunities for advancement and discovery in our comprehension of the universe. For the rest of us, it will be a reminder of the incredible mystery and beauty of the universe we inhabit.